Welcome to the second part of lesson 5 here. We're going to talk about the cosine law. And in the cosine law, the learning target here is solve problems that involve sine law, cosine law, and trig ratios. So that's learning target 5, but really the new thing we're going to talk about today is the cosine law in this lesson. And but the learning target really is solve problems that involve any of those. But first, we're going to start by talking about the cosine law, and we're not actually going to prove it, but I'm going to show you kind of a neat idea that helps you really understand the formula without knowing the proof. And so if we look at the first one here, like we actually see that the Pythagorean Theorem will quickly solve this. And so then the question becomes like, how long would C be versus 13, which is like the C in the first one. And so if you see this, I'm just gonna, that guy keeps covering the 13, but if you see this angle here is 90, and these are the same dimensions, so what happens is this angle just closes down. You can understand that this is actually going to be lower than 13. And if 90 is here and this angle here just opens up, we can see that this is actually higher than 13. So the question is, how much lower or higher? And so the answer is actually from the cosine law. It's 2ab cosine C. Now it's not exactly how much lower or higher, because that's actually before you take the square root. But the cosine law actually does that, where you actually subtract 2ab cosine C. And so like the question then is like, well, how does it get higher? And so I'd always pose that to you and see, how does that get higher? The question does, this formula really closely resembles Pythagorean Theorem. It's actually very, very similar to Pythagorean Theorem, but you have another factor that gets subtracted off. I would actually not get too hung up on the labels here. So my advice for you is to really just look at one version of this formula, even though in a lot of places you're going to actually see 3 versions. The 3 versions is good conversation because it's just showing that it doesn't matter where you are in the triangle as long as the angle is across from the side that you're finding. You can also find angles this way by like subbing in value for C, A, B and doing a little bit of algebra. If you want to do the algebra once, you can say that the cosine of C is C squared minus A squared minus B squared over negative 2AB. I always like to ask this question though, is if you're going to be higher than 13, how is it going to be higher if you're doing subtraction? The answer lies in the fact that if you do the cosine of an obtuse angle in the second quadrant, your angle is going to be a negative. And we're going to see that in a second. Okay, just some examples. When you read these examples, you really have to put yourself in the situation. So as you read them, you really want to draw the picture and just write down what you're given. So 2 forest fire towers are 20.3 kilometers apart. The towers make a triangle with an observed fire. The angles are 45 degrees and 80 degrees at towers A and B. How far apart is each tower? We're trying to find out how far apart are these two, or how much are these two sides. So we look at this question, we ask ourselves, okay, if we have a match side across from an angle, we can actually use the sine law, and that's actually preferred. If you think that the cosine law is the easiest thing to do, you really need to use the sine law more, because it's actually way easier. You're going to see that today. So the question is like, do you have this angle across from the side? And the answer is yes. If we subtract from 180, we can say this is 55 degrees. Now what I would say is we have a match. We have a side across from an angle. And we can use that match to solve for another side. I always like to put the side in the top corner when we're dividing. Just it limits the cross multiplying. So A over sine 45 is sine 20.3 over sine 55. And cross multiply sine 45 up once. And all in one in your calculator, you can say that the answer is 17.52. Similarly, we can do B, and we notice the match B is across from 80, C is across from 20.3. Cross multiply and you get 24.41. And so that's how far the fire is from each tower. On a hiking trip in Algonquin Park, two hikers separate from their group. Each becomes lost. Both hikers go to wide open clearings where aircraft can see them. After several hours, the larger group contacts the park rangers to tell them of the lost hikers. Rescue helicopter at an angle of 200 meters spots both hikers at the same time. It's actually a really famous triangle. It's really just a pyramid, and so we can see just really the bottom here of where the rescue helicopter is. We get a height of 200 meters. Angle of so the 142 degrees is between the two hikers, and so here's the position of hikers A and B. Angle of depression is actually the same as the angle of elevation. So the angle that the helicopter looks down at both hikers is the same thing as the angle that the hiker looks up. If you drew like the Z pattern, you could see that if you had this angle here, which is the angle that the helicopter looks down, it's the same as the angle looking up. So it's the easiest thing to do is just put the 9 and the 13 as the angles of elevation. We're trying to find out how far apart the hikers are, and so we're actually using this triangle here because the 142 degrees is there. We don't know a lot about this triangle here, but we know we have two other triangles that we can look at as well. It's a little deceiving. These two triangles are actually 90-degree triangles. That's really important to notice. We can actually use SOHCAHTOA then to find out why. Tan 9 is opposite over adjacent. This is a 90-degree triangle here. If you can't see that as a three-dimensional picture, what you could do is redraw that triangle in 2 dimensions. You cross multiply like the y up and the tan 9 down. You get 200 over tan 9. And so you get a number for y. Similarly, we can get what we call z. Tan 13 is 200 over z. Cross multiply, we get 200 over tan 13. And z would be 866.3. I purposely tried not to round here just for accuracy, but I mean, if you round it a little bit, like it's just more accurate if you keep as many decimal places as you can. Now you've got these two sides. We actually don't have a position. We're not in a position to use the sine law because we don't have a matching side across from an angle. So we have to use the cosine law. And we use the cosine law kind of like Pythagorean Theorem, where x would be the hypotenuse, except again we subtract that factor, the 2 times the one side times the other side times cos 142. It's a big ugly formula. It really does look ugly. You just got to take one step at a time. So the first guy is the square, the second guy is the square, and the third guy is the 2 times this times this times this. Notice how the plus comes in because cosine 142 is an obtuse angle. So this a negative times a negative becomes a positive. Okay? 142 is in the second quadrant where cosine is negative. So yeah, x squared is 4 million. And then x is 2017, which is really nice because it does make sense as an answer. Last example, very similar. Top of 50-meter high bridge, 2 boats are seen at anchor. One boat has an angle of depression of 38. The other boat has an angle of depression of 35. The angle between the lines of sight is 110. That's a little bit different than the triangle we saw before on the ground. But it's going to be a very similar question. The lines of sight is this slanted triangle that the bridge is looking down on the two boats at the same time. Similarly, we're going to find out the side x first using SOHCAHTOA. Cross multiply and get a value for x. We're going to find y with SOHCAHTOA. Almost the exact same calculation. And then, so to find z with x and y, we're going to use cosine law, and it's almost the identical problem to the last question. I'm just going to go back for a second, except instead of tan, we're using sine, and it's really just where that triangle, that angle is. So it's almost the identical problem. It's just where this angle, it's the difference between the angle on the ground versus the angle at the bridge, at the lines of sight. So there's about 4 questions to practice there that are 3-dimensional drawings with sine law and cosine law.